Hello everybody and welcome back to Kerbal Space Program, where we are just making a quick stop at our Minmus station to refuel before we head off. So first things first, we need to figure out where exactly we are going to dock this thing up. And I think the answer is right here. So we will control from here. We will set this crew hatch as our target, and we will point to target. Excellent. I would physics warp this, but it can get a little wacky physics warping at the station. So we'll just hold off on that for right now. We'll just allow this to slowly drift into position, utilizing our many reaction wheels on this thing. We should be in position quite soon. And also, let's check our fuel levels. Our fuel levels are plenty high. Excellent. We have no ore on the station right now, so that's a thing we're going to have to keep in mind. I also made a slight change to our trajectory. We were still coming in at about 0.2 meters per second, so I pretty much stopped that. It's still moving a little bit, but it's not very much. It's less than 0.1 meters per second, so we should have enough time for this. I'm going to freeze this physics just to let us get lined up a little bit more quickly here. Excellent. And there we go. We are pretty much lined up. I'm going to freeze those physics. Perfect. Now we'll hop over to this ship. We will go ahead and open this airlock. We'll set this guy as our target. It's already pretty close to there. We'll point at target. Looks like we're drifting a bit over here. Oh, hello. RCS on. I don't want RCS on right now. Okay. Freeze that physics right there. Excellent. Point at that target. And we will simply move in at about 1 meter per second for right now. Now I'm just going to adjust our trajectory slightly. There we go. We'll point directly at this target. And we're going to need to cut our speed in half here pretty soon. So we'll just let this come in until we are about 30 meters out or so. It's definitely swaying a lot more than I'd like to see. So that's going to be interesting. Okay, we're doing reasonably okay right now. Going to cut our speed down to half. 0.5 meters per second. Just making a slight alteration to our trajectory there. Hopefully we can compensate for this sway. It's definitely proving challenging, but I'll just adjust our heading a little bit there. Or rather, our trajectory. And then get our heading in. And this should be a dock up right here, in theory. Oh, that thing is swaying so far out. It's moving so much. But I think we're okay. Bam. Oh. It didn't quite dock. It may yet get there with this sway. There we go. Okay. That sway was exciting, to be sure. But now we will just simply pin this open, as well as this open. Excellent. And we will just start transferring some fuel and oxidizer. This will, of course, not be enough fuel out of this tank. We're going to have to put in another tank. but that's okay. We'll just fill this thing up. This is, of course, at this point, more full than this has ever been, because we launched with this tank completely empty. Oops, I did not mean to close that. Get that last little bit of fuel and oxidizer out of there. Does not want to pull out of this tank. We'll see if it'll pull out of this one. Yeah, that'll be fine. Okay, and there we go. We are ready to leave this station now. There's nothing else to be done here, so we are simply going to undock, switch to this ship, and just RCS right on away. There we go. Excellent. Now we'll just let our distance build up a little bit, and we will simply figure out where we want to burn to escape here. I mean, that would do the trick in theory. Our inclination is going to be definitely a bit off, but we can fix that. Can we make this any cheaper? Oh yeah. We can definitely make this quite a lot cheaper, in fact. Saved about 15 DV there, I think. I'll allow it. So we'll get aligned up here. We're not going to physics warp this close to the station. That can cause issues. Excellent. There we go. And we are going to warp to this next maneuver. Excellent. Goodbye, station. I don't know where you are right now, but we are about 4 kilometers away. You're up over there. Fine. Okay, so our solar panels are oriented awkwardly. Let's do that so we catch the sun slightly better. This is going to be a burn time of 17 seconds. Or rather, 34 seconds, so we want to burn at T-minus 17. So we'll just warp towards that. Right about now. Off we go. And this is escape velocity. Well, it will be. I mean, we're escaping min-miss, to be sure. About 40 more meters per second left in this burn. Make that about 10. Is that an escape? That's an escape. Fantastic. So that's going to be 38 days for that. And that will set us up on this course. So, of course, we're going to want to set the solar gateway as our target. And 0.7 degrees at the ascending node. Are we going to be going up or down? Looks like we are going to be pointed at the descending node. Actually, this is fine. Just saving as much DV as we can here. Looks like that's it. Excellent. So we'll point at that maneuver. And that should do the trick as far as that maneuver goes. That node is in 1 year, though, so it'll be a while. So let's hop on back to the Space Center and see if there's anything we want to do here. We can check in on our long-term missions and maybe set up another mission, because we've got quite a few long-term ones that are quite a ways away. Extract units of ore from Minmus. We can grab that. That'll get done eventually. Flag on the surface of the moon. This is splash down into the oceans of Eve, walk on the surface, and return to Kerbal. That's a lot. We're not going to do that just now. We're focused primarily on our solar gateway for right now, and until that gets done, which might be the end of the series, we're going to focus primarily on robotic exploration, but maybe the time has come to land something on Duna. So that would be essentially a variant of the Science Rover Mark Eve, which is, of course, this guy. We would still have the giant heat shield on here, not to protect us from the atmosphere, but to act as kind of an inverse parachute. And this parachute would have to go, and would have to be replaced with something more like what we used to land the rover on Ike. Was that Ike? Where did we land that rover? I can't even remember. Oh, that rover was on the moon. What am I talking about? So this would just be like a T200 fuel tank here. There would need to be a decoupler on top of this, of course. That'd be a TD12, probably. Yeah, that'll do. Okay, and then we would, of course, have our landing abilities. So, well, I don't know what I'm trying to say here. Landing abilities? What is that even supposed to mean? We'd just have a modular girder segment poking out kind of like this. Excellent. And then we would have 4 twitches. I want to make sure that they're properly rotated. That would help. There we go. That's more like the direction I'm looking for. And something like that. Then we'll just snap them into place with the move tool to make sure that they are correctly placed. There we go. Nice and symmetrical. Okay, so that would be the overall landing strategy, although we may want to, instead of using the modular girder segment, maybe use the cubic octagonal strut. What's this thrust to weight with these engines? Also, what is this decoupler? No, seriously, what is this decoupler? That decoupler. Well, that's definitely not the one that we want to use there. That decoupler would be down there. We'll deal with that in a moment. We're going to have to redo the fairing, of course. For right now, we will go ahead and delete that fairing, because that will require redoing. This would be 1.4 thrust to weight on Kerbal altitude. Kerbal sea level would still be 1.4, but what about Duna sea level? 4.9. That is plenty. 726 meters per second? Oh yeah, that should definitely get us there. We might want to tack on a pair of drogue chutes, just in case this is insufficient, but we're probably going to do another simulation run. So for right now, let's go ahead and tack on those drogue chutes just as a test. So the drogue chutes would go like here and here. Kind of like that. And then let's redo this fairing. So the fairing is going to need to be a little bit bigger than the Eve fairing. Something kind of like that should do the trick. Excellent. And we'll save this as the Science Rover Mark Duna. Okay. So we're going to have to adjust our staging, of course, and then we'll do a quick simulation like we did with Eve. So this is fine here. This is fine. Those two stages look good. All of the SLS stages actually look good. So that would decouple. We want this to fire separately, so that would be fine. The drogue chutes should probably be in their own little thing here. And then that decoupler, we definitely want it to be on its own. And that's... Is that the heat shield decoupler? Yes. The heat shield decoupler should be, like, over here. Certainly before the landing apparatus decoupler. Okay. So something along the lines of that would be what we'd be delivering to the surface of Duna. So for right now, let's save this, make sure that's saved, and we are going to ditch the side units, as well as this. We'll bring this down to about half fuel. I have no idea how much fuel we'd actually be at there, but it would look something kind of like this. So I'm not going to save this, and we're going to launch this, and we're going to put this in orbit over Duna. And we're just going to see how an entry through a simulated Duna atmosphere would look. So we would deploy this fairing immediately. The fairing is not needed. And then we will simulate an orbit over Duna. Like this. We're not going to grab any of this. We're not going to grab any of the messages that we get here. This flight will be reverted. So we are currently at a kind of awkward position. We'll go ahead and position this way, and we will, for the time being, extend our solar panel, just to make sure we have some power supply. Excellent. The Duna atmosphere begins at... what? You know, I don't remember. Focus Duna. There we go. That's what I needed to do. Atmosphere begins at 50k. Fine. Okay, so we're going to fire that engine and bring this right on down to about 20k. Oh, we don't have probe control right now. We don't have a satellite here. That's probably something that we should fix before we run this mission. For right now, we'll keep operating like this. So we'll go ahead and warp to here. Actually, we'll warp to here. And we want to be testing essentially an uncontrolled entrance, as if we had no fuel left in this tank. So we're just going to be ejecting this entire tank. And that is, I believe, this decoupler. Yes. So we'll get positioned. We'll eject this tank. And we're going to run a test to see how effective this heat shield is here. I actually have no idea. The Duna atmosphere is super thin, but also this is an enormous, enormous shield that might as well be a parachute. So we're going to do something like that, actually. And I'm now going to just warp forward for a little bit until we're actually within the atmosphere. But we've already learned some things from this simulation. First off, we need a communication satellite here. Okay, we're about to hit the atmo right now. There we go. This should be plenty of SAS. I'm going to retract this panel, even though it should be fine behind this. Actually, this is a simulation. I want to know if this panel would be fine behind this heat shield. It should be fine. But this is one of the things we'll test. I mean, it looks reasonably fine so far. Look how thin the Duna atmosphere is. It's insane. Very, very little atmospheric drag slowing us down right now. I mean, at this angle, it may require multiple aerobrake passes. But that's the reason for the simulation, is to figure these things out. The other question is, with this solar panel extended, does it get destroyed by this exhaust? That's something that we need to think about as well. So we'll see. What is our time to to periapsis? Our time to periapsis is currently going up. Okay, so we are not going to be coming back out of this atmosphere. We are not going to be bouncing. Sounds good. We're slowing down pretty dramatically now. Funny thing is, we're still falling behind the Science Rover Mark Duna. Which I guess that makes sense. We're slowing down, and it's slowing down less dramatically. So far, this seems to be okay on the actual deceleration front. We're not using this heat shield, again, as an actual heat shield. We're using it as a reverse parachute. And it's doing its job. It's doing its job very well. We don't care about these world first milestones. We are not going to be looking at those. This is simulated. This is just to acquire data. And we already know now that this solar panel appears to be fine through the atmosphere. We also know that we desperately need a communication satellite in the Duna system, and that will probably be our next priority. And we'll send that before we send this rover. So, what else do we find out? Well, we're going to be landing, looks like within this little trench here, is my guess. We're not slowing down super quickly right now. We could deploy the drogue chutes. And I'm going to do so. They should now be armed. Yes, so they will deploy as soon as we are within the minimum pressure threshold. So here's the Eastern Canyon. Okay. And the science rover has actually managed to not quite be caught by the atmosphere. And you can tell that's the difference between this heat shield and not having it, is that we would have bounced out of the atmosphere this time. Needed at least one more aerobraking pass if we had not had this. So when are the drogue chutes going to be deployable? When we reach here, perhaps? We're very close. We're about 20 kilometers up right now. Our next spacebar activation drops the heat shield. We're still considered flying high. And we're still decelerating, which is a very good sign. Do we need the drogue chutes at all? It's starting to look like we don't. I mean, this heat shield is very effective in this job. Anywhere where there's any atmosphere at all, this is a pretty effective thing to do. It looks like our deceleration is slowing, though. Those drogue chutes still have not deployed. We're 10 kilometers up right now. Intriguing. Nine kilometers up. 8 kilometers up. We are currently 7 kilometers up, and the drogue chutes still haven't deployed. We are still decelerating, so that's good. We've not activated the engines yet. We should probably do that. There we go. So now the next spacebar will do that, and there goes our drogue chutes. Okay. Currently about 3 kilometers up. We should probably ditch our heat shield quite soon, now that our drogue chutes are out and deployed. I'm going to ditch the heat shield. And make a little space between us, because we were catching up to the heat shield there. And I was not a big fan of that. So this is going to be a really difficult landing, and really loud. I apologize for the loudness. But I can only go from full throttle to no throttle because of our lack of probe control right now. So I think we've learned what we need to learn. This landing is eminently possible like this. That thing actually survived its landing. That's exciting. But this would be very difficult to land this thing without having proper probe control. Possible, but difficult. We're just kind of bouncing right now. Oh my. Yeah, so that's the issue. And I'll just let it settle. Okay, so yeah, that's doable. Exciting. The brakes are on. They're not good enough. Let's just crank those brakes up. Now they're good enough. Okay, so we've learned a few things, for sure. So we are reverting that back to vehicle assembly, as we expected. And we are going to open up the Science Rover Mark Duna proper. And that's this guy right here. And we have learned a few things. First, I don't think these drogue chutes necessary at all. I do not think that's the case. Second, our brakes definitely need to be maxed out. There we go. Third, we need to send a communication satellite, but that is a job for the next episode. You can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and next episode, we are going to send that communication satellite up. See you all then.